7.1 sets. Okay, so we start off and we have different set notations. We've got a list, which most students like, and we've got set builder notation, which most students hate. But they're both pretty much trying to do the same thing. We're listing out some items in a set. Set A contains 5 elements, A, B, C, D, and E. Set D, okay, let's look at this. Set builder notation starts with a variable. And so we've got the set of X, which is a variable, such that X is one of the United States. So students hate this notation because it looks confusing, but you've got a variable and you've got a rule. But think of the alternative. Everybody likes a list, but what this would entail is you'd have to list out all 50 of the states. Well, I don't want to do that. I don't want to list out 50 states. And so this rule is actually more efficient, a more efficient way of naming the set. So we've got some variable such that that variable is one of the 50 states. Set B is another list, and we look at set E, and it says we've got some X such that X is a natural number, less than 8. Now, if you recall, a natural number is a counting number. So just start counting. 1, 2, 3, 4, 5, 6, 7. No, we better stop because we're less than 8. So if you think about it, 1, 2, 3, 4, 5, 6, 7, it's exactly the same thing as this. And so, yeah, I'd rather list them out here, but I sure wouldn't want to list out the 50 states. So sometimes set builder notation is more efficient, but sometimes a list is more efficient. So keep that in mind. Now, we've got a whole bunch of new symbols, and I think that's why some students will struggle with this lesson, is because of all of the new symbols. This isn't even all of them, but it's a lot of them. This symbol right here is called the empty set. I look at sets as being like a box. And if you think about a box, you've got a box, and this first box A has 5 items in it, but you might also have a box that's empty. And so if you had a box that's completely empty, there's nothing in it, that's this symbol, empty set. Empty set. This symbol right here is supposed to look like, oh my gosh, it's supposed to look like an E. So it's is an element of, is not an element of. These are probably the hardest ones. Is a subset of, is a proper subset of, is not a subset of. And then there's this, a complement. I like to read it as not a. And then this letter N stands for the number of elements in A. Okay, so let's do an example here. If I said 3 is an element of, you'd say, well, I see 3 right there. 3 is an element of set B. That's one way to do it. There's another answer, though, because remember, this was the same set. A natural number less than 8 would also work. So I could have said E. Next one, 5 is not an element of. And so there are a couple of different ways you could answer this. You could say set A. I think that's the most obvious choice. 5 is not an element of set A, but you could have said D. 5 isn't one of the 50 states. Number of elements in A, I already mentioned it. You just count them. There are 5. Number of elements in D, that's this one. Well, it's one of the 50 United States, so the number of elements in that set is 50. B equals, we already talked about it, but B is equal to set E. They've got the exact same elements. Now we talk about subsets, and again, I said this before, but I think subsets is probably the hardest part of this. Look at F first. F, talk about a state bordering Indiana. So if you think about Indiana, okay, you've got Michigan up here, and you've got Ohio over here, Kentucky down here, and Illinois over here. So we can see that there are 4 states bordering Indiana, but that's set F, is if you listed out those 4 states. F is a subset of set D. Think about it. It's just, if you had let's say you had a box and you had a list of the 50 states inside, okay? A slip of paper, each slip of paper has the name of one of the states. You reach your hand in, you grab out 4, okay? Or you grab out any number, really. You grab out some subset of the 50 states. But in this case, we've got F is a subset of D. Now let's go back. B is a subset of, well, one answer is E. There's another answer on the board there, but that's probably the most obvious. Now, if you notice, you've got this symbol and you've got this symbol, and both of them are talking about subsets. You may have guessed you're going to use this extra little piece when it could possibly be equal to that same set. You would use this symbol when we know for sure that there are fewer items in the subset. Last one here, set A is not a subset of, well, one way is to say this is set D. There are other ways, but that's one way to answer that question. Number 2, true or false? Well, if you look at it, they have the exact same items. It doesn't matter that one of them's mixed up. Think about putting the numbers in a box and shaking up the box. They've still got the same items. Those two sets are equal. Next one, we've got this is a subset of this. Well, no, it's not, because you would need a 12. You would need an extra element there. Subset properties. The empty set is a subset of every set. Number 2, a set is a subset of itself. Okay, so think about it. You've probably seen on TV or something, there's this booth, and a person stands inside this booth, and then like a wind machine kicks up, and all these dollar bills start flying around, okay? Seen that? So imagine what this person could possibly walk out of that booth with. They could walk out with all of the dollars. That's like a set is a subset of itself. Or they could walk out with no dollars. Maybe they didn't grab anything and they walk out with nothing. That'd be like the empty set. Or probably more likely, they collect some of the dollars, but not all of them. Anyway, when we're talking about subset, it's just what's possible, okay? Could they walk out with everything? Could they walk out with nothing? Could they walk out with some of the things? Those are subsets. A set of k distinct elements has 2 to the k subsets. That's trying to tell you how many. So example 3 says list all possible subsets for each set. It's easier to tell how many there are. And so, since there are 2 items, there are 2 to the second. K equals 2, so 2 to the second equals 4 subsets. So think about my cash booth example again. All right, let's say there's a $7 bill and an $8 bill flying around in that room. Okay, that person could walk out with nothing, or a $7 bill, or an $8 bill, or they could walk out with both of them. Those are the 4 subsets. It's just whatever is possible. So when we look at part B, since there are 3 elements, there would be 2 to the third. 2 times 2 times 2 is 8 subsets. And so again, think about what is possible. You could have nothing, just an A, just a B, just a C, A and B, A and C, B and C, or you could have all of it. Now keep in mind, the empty set is a subset of every set, and a set is a subset of itself. So both of those hold true. You got the empty set and you've got the whole set. Number 4 says find the number of subsets. We already did that. It's 2 to the k. It's 2 to the k. So in this case, 4a, there are 5 elements. So 2 to the 5th power. That's 32. 32 subsets. Set B, X, such that X is a day of the week. Well, we know that there are 7 days of the week. This is going to be 2 to the 7th, which is 128. Empty set. Okay, think about that. Booth's empty. There's no money in there. There's nothing flying around. It's empty. There's only one possibility, or 2 to the 0. Okay, you have 0 items in the booth. There's only one possibility. You're getting nothing.